If we're presented with some data, how could we decide between a linear model or an exponential model to represent that data? Recall that linear functions are useful models for repeated addition, and exponential functions are useful models for repeated multiplication. How could we decide between the two? Let's first think about how we might try to fit a linear function to this data. If I look at just the first two pieces of data, for a linear model, I would be interested in what's the additive change. That is, what value did I add to 10,000, which is the first output, in order to reach 7,000, which is the second input. As an equation, I'm asking 10,000 plus what is equal to 7,000, or in other words, the thing that I'm adding is 7,000 minus 10,000. In general, what I'm really looking for is the difference between two consecutive values. If I thought an exponential function would model this data well, then I would ask a different question. What value should I multiply 10,000 by in order to reach 7,000? That is, 10,000 times what number is equal to 7,000? And if I solve for that number, then it's 7,000 divided by 10,000. So in general, for an exponential model, I'd like to divide consecutive values. I'd like to divide the later value by the previous value to see what number I need to multiply by to step forward in time. If we return to our data now, let's compute the additive change for each of our consecutive values. So for the row with x equals 1, I want to take 7,000, which is my current y value, and subtract 10,000, which is my previous y value, in order to determine what it was I added to 10,000 in order to reach the current value of 7,000. And similarly for the row with x equals 2, my current y value now is 4,900, and I want to subtract from that my previous y value, which is 7,000, in order to determine what did I add to y equals 7,000 in order to arrive at the y equals 4,900 that I currently have. And we do this for every row. When I simplify all those, I see that my additive change is not constant throughout. It's not even close to constant throughout. This suggests that a linear model may not be appropriate. What if I compute the multiplicative change now? For the row with x equals 1, I take 7,000, which is my current y value, and divide by 10,000, which is my previous y value, in order to determine what did I multiply 10,000 by in order to reach 7,000. And the row with x equals 2, my current y value is 4,900, and I divide that by 7,000, which is my previous y value, in order to determine what did I multiply 7,000 by in order to reach my current value of y equals 4,900. And we do this for every row, and when I simplify those, I get a value of 0.7 for every row. This means that an exponential model not only is a good fit, but it's actually a perfect fit for this data. Moreover, I know what that model should be. My initial value is 10,000, and my growth factor should be 0.7. This is the constant multiplicative change that we found by comparing consecutive data. So I get an exponential model of 10,000 times 0.7 to the power x.